right, welcome to the next episode of Voice AI podcast, where we discuss the future of voice AI. Today, I'm super excited to host Russ, who is the co-founder and CEO of LiveKit. Russ, welcome to the podcast.
Hey, David. Thanks for having me here. I'm excited to be here.
Yeah, super excited. Look, as always, I'm gonna take my shot to do LiveKit introduction using my ChatGPT friend here.
Let's do it.
So LiveKit is an open source platform for building real-time video, audio, and data applications. It provides infrastructure for WebRTC-based communication, enabling developers to create scalable, low-latency video conferencing, live streaming, and interactive applications. LiveKit offers both the self-hosted and cloud deployment option and includes SDKs for web, mobile, and backend integrations. It is commonly used for applications like virtual events, gaming, and remote collaboration. How was that?
It's not bad, but I gotta seed it with all this AI stuff that we're doing now.
Yes, I know it's missing, right? So I know that you guys have added LiveKit agents.
Yeah,
You have like whole framework about on top of your basic infrastructure,
that's right.
and I think like we're gonna do a deep dive on that today. But yeah, welcome again. I'm really excited about this conversation.
Yeah, thank you so much. It's been a crazy kind of evolution of the company since we started. I don't know what the knowledge cutoff is for the ChatGPT, but yeah, a lot has happened since its knowledge of what LiveKit is.
And when did you guys start? How
We
many
started
years?
we started about 3.5 years ago. So we started in the pandemic
Wow.
in 2021, and yeah, a very different time in the world, right? We were all stuck at home, and the only way to connect with another human being was through your camera and your microphone on your computer. And so we were building uh, infrastructure back then, open source infrastructure back then that made it easy for a developer to connect their users with other users of their application using this infrastructure. And then I guess over time, what happened, and we can go into the whole story because it's a pretty fun one. But over time, how LiveKit was being used was, instead of connecting human to another human, it started to become pretty common for people to connect or want to connect a human to a computer or to a machine or to an AI model. And so you've kind of seen LiveKit also move in that direction as well, and kind of get into building all types of AI-based infrastructure for that particular use case too.
Very cool. But like I didn't realize LiveKit is open source, so like one can take it and host and power their own infrastructure, and you have the enterprise sort of package,
Yeah, it's
or
so
not?
weird.
Yeah.
It's weird because when we started, we were just an open source project. We were a few people, and
Mm.
all over our website, we put open source, open source, open source, just so like people knew that there was no vendor lock-in. You could go and deploy this yourself. And of course, we have a version of our own that we deploy and scale and run in the cloud as a commercial offering. But in the early days, 2021, 2022. 2022 is when we actually, at the end of it, was when we launched our LiveKit Cloud, which is our commercial offering. And some really large companies were coming to our website, and they were messaging us and saying, well, are you guys just you're just an open source project? Like, is this thing going to actually scale and work? And we were like, wow, man, what do we do to get these customers to believe that this tiny open source project can actually scale to their needs? And so we linked to GitHub in the corner, and then we removed all the words open source from the website. And then now we have lots of, I think it's like maybe 30 or 40 Fortune 500s that use LiveKit, and some of the most valuable private companies in the world use LiveKit. And so we have their logos on our website, but we don't have the open source language anymore. And so people are like, wait, you're open source? I didn't realize you guys
Yeah.
are open source. Aren't you the enterprise solution? You have all these logos on your website. I'm like, yeah, it's both really, but I gotta do something about that.
It's good to know the story actually, and I wonder like for LiveKit, open source LiveKit, I mean, one would still need to have a decent infrastructure to power this, like from latency perspective. So it's not easy to use that as an open source, right? Like,
It's definitely
like
not easy. So there are companies out there that do go and deploy it and kind of figure out how to operate it at scale. Um, LiveKit is a collection of things. So it's the core real-time WebRTC infrastructure. There's something called egress, which is how you record these streams and be able to store them and watch them later. And then there's ingress, which allows you to pull in streams of video or audio from other kinds of formats or other devices. So you can think of a courtside, like a camera, a broadcast camera courtside at a basketball game, that's speaking SRT or another kind of format. And that's not the real-time WebRTC format. So you need to kind of transcode that and be able to pull that stream in if you want to have access to it and, you know, have a shared experience where everyone can watch a basketball game together with ultra low latency. And so that's what Ingress does, is it does all of this conversion to the WebRTC native RTP format. And then we have telephony, which is like a SIP stack for doing telephone calls and being able to bridge phone calls into WebRTC. And then we have agents, which is like a framework on the back end for being able to consume these audio and video streams and stream out audio and video streams from a server side program, which is what the AI use case kind of leverages heavily. All of these things are open source. So the entire stack, right, from the bottom to the top is open source. There's one part of LiveKit that is proprietary and closed source, and that is we have a piece of software that allows us to spin up LiveKit servers all over the world. So thousands and thousands of servers all at the edge. And then they all kind of act as one massive server. So it's a distributed system and all these servers intercommunicate. And the latency benefit of having that kind of system in our commercial product is that, you know, if I'm in San Francisco, I'm connecting to a San Francisco server, and then someone in Australia is connecting to a Melbourne server. And then those servers, I'm sending my audio and video to that San Francisco server, the other person to the Australian server. And then those two servers, because they're part of one massive kind of network or a single piece of infrastructure, they forward their streams over the private internet backbone between Australia and San Francisco. The way I kind of explain this to people now, I finally came up with something good, is that there's kind of, I'm going to ignore Australia because that's going to kill my, my metaphor, my analogy here. If you have a user in New York and a user in San Francisco, and you want to send data between them, in the physical world, if I want to go to New York, I have a couple of different ways I can do that. I can drive to New York, which is like sending your data point to point, peer to peer over the public internet. Or I can drive to SFO, I can get on an airplane, I can fly to JFK, and then I can drive to Brooklyn from JFK. Right. And so that's the analogy of how it is to use LiveKit Cloud versus using just regular WebRTC, not even LiveKit. So if you're just using plain vanilla WebRTC, you're going over the public internet. And if you're using LiveKit Cloud, you're using airports and airplanes. So it's a faster path for your data to travel.
Yeah, absolutely. I think that makes a lot of sense, and that's the key ingredient of your commercial offering, right? Because yes. Like if we are building a WebRTC app or like an app with communication, like that's really key. The latency is key. I remember, when I was at Twilio, I was looking at such frameworks a lot, and I was just amazed. I mean, it's not an easy thing to do. Like, I'm sure you have a lot of IP there, and how you route packets and how you determine like the fastest path there. So there's a lot of complexity around this. So very, very cool.
Fun fact. I don't know if it's a fun fact, but it's a fact. That LiveKit is, it's a collection of a lot of different tools, all for dealing with media and real-time communication and data streaming. And the LiveKit Cloud, that piece that's kind of the software-defined networking piece that does all the routing and management of these streams over the private internet backbone, is as much code as all of LiveKit open source combined. So it is one of those things, not that the amount of code is necessarily like a thing to be proud of, but it is a very complex problem. That's what I think I'm speaking to there. As you said, it's a hard problem to solve, and it does require, there's a lot of nuances that you get into once you dig into the problem and start to actually try to solve it.
Yeah, no, it's super cool. And if you look at this stuff, I mean, it's pre-Gen AI problems, if you think pre-AI problems,
I
right?
know.
Yeah,
Yeah.
we used to call it machine learning back then. It's still machine learning, but
It is still machine
pre-AI
learning.
pre-AI problems. And yeah, I'm really curious, Russ, to understand and learn how what happened after Gen AI for LiveKit, and how you have approached, how you have designed the agents framework, and what one can do with this framework, and then how you envision it evolving over time.
Yeah. So I think a story best told in like three parts. So the first part is, how did this even come together? WebRTC was designed to be a peer-to-peer protocol. So it was designed for a client device, a phone, a laptop, an Apple Vision Pro, whatever kind of device, to directly connect to another device, another person out there in the world. That's the default design of the protocol. And so what we did, well, we built a bunch of infrastructure to make that scale and all of this, and I won't get too deep into that part, but peer-to-peer protocol means it was designed to run on a client device, not designed to run on a server. And so what we had done, I think ChatGPT had come out, the website, not an API, just the website. So I thought, oh, it'd be pretty cool to like talk to ChatGPT instead of text with it, because like this AI model can like respond convincingly, like it sounds convincingly like a human. So we had an SDK that was written in Go, and it allowed you to write a server-side WebRTC program. So you could kind of do similar things to what you do on a client when you're using WebRTC, but you could do that in a server program. So you could write a Go program, and it could pull in an audio or video stream from a user out there that's streaming it in as if they're streaming it to another human being, but now it's going to this program. And then the program can process that audio and video in some way, and then it can actually send out audio and video if it wants to back to that user. And so took that audio data from the user, transcribed it using, I think it was Google SDT at the time, very slow, but it worked, into text. And then took that text, and I was running a puppeteer session with ChatGPT, a headless browser, and I piped the text into it and like hit the submit button, so it would programmatically hit the submit button, so it would start to do inference. And then as those tokens came into the div on the page, I would read them out, and then I would convert them into speech back in Go, and then stream them back out to the user. And so kind of doing this loop using WebRTC and streaming all the things, I wrote a blog post called ChatGPT plus WebRTC, and it kind of went through, how this was done and how we built this thing. And about 4 or 5 months later, OpenAI ended up finding it, and they were working on a project called Voice Mode to provide a voice interface to ChatGPT, similar to kind of like this thing that I hacked up. And during that time, so after we wrote this blog post about this Go program that we built, we started to work on a Python SDK. And so, machine learning, AI, it's all kind of Python, at least right now, is the main language people use. And so, kind of saw that early before OpenAI got in touch. And so we had this Python SDK, and they had been exploring LiveKit Cloud and playing with it, and were impressed by the latency and just the developer experience of using it. And so we started to work together on Voice Mode. And so we built Voice Mode with them. And so that's the kind of the not quite the end of the first chapter of this story, but we built Voice Mode with them, launched it. And right before GPT 4.0, that demo that kind of broke the internet, which LiveKit also powered all of that too, everything you saw there, at least from the networking transport part of it, we learned a lot from working with OpenAI on voice mode and then advanced voice mode. And what we ended up doing was extracting a lot of the learnings that we had from building that product with them into something that we call the agents framework. And so, we had a Python SDK, we had a Go SDK, and those things were like very kind of lower level. They let you just have access to like the core WebRTC infrastructure. And then what we did was we put another layer on top of it called agents. And agents does a few things for you. The first thing that it does is it sits on top of the Python SDK, and now we have a Node SDK. So we have an agents.js and we have an agents Py. And what it does is the first thing is it gives you kind of that access to WebRTC, right? You get a super fast, low latency kind of streaming transport on the server. That's the first thing. The second thing that you get is you get kind of like a plugin architecture that makes it easy to pull in different types of services from providers. So on the audio processing side, there's STT providers like DeepGram and 11 Labs now has one, and Google and Azure, et cetera. On the LLM side, there's multiple foundational models that you can, plug into and integrate with. So like, of course, there's OpenAI and the GPT class of models. There's Claude. There's other ones too, Perplexity and Grok and et cetera. And then on the synthesis side, like audio synthesis side, there's providers for taking text and converting it into speech. Beyond that, then there's also like video processing. So how do you do computer vision types of stuff? You can actually build that using the agents framework. There are a host of avatar companies that are doing generative avatars and generative video. We have plugins for that. So you can weave that into the agents framework or plug it in, and we automatically handle things like synchronizing the audio and video and stuff like that. So that's the second part of what the agents framework provides. The third part is orchestration. So, depends on what you mean by the word orchestration. You could think of like the plugins and all of that stuff as orchestration. The way that I'm phrasing it, maybe I need a better word, is what's different about this architecture, the architecture of voice mode, and a lot of voice AI applications that people are building today, is that it's not stateless like a web server and a web application. So in a web application, you click a button, you fill out a form, you wait, the data kind of goes over the network, gets processed, there's side effects, database is updated, et cetera, and then a response is generated and sent back over the wire, and then your application re-renders. What's different about these types of applications is that you are constantly streaming audio. And so whatever is on the back end that needs to process that audio while also talking to an LLM on the other side, there needs to be some stateful component that is constantly listening to what you're saying. Are you interrupting it? Are you asking it to do something else? It can't it can't be like kind of this async behavior where you're done sending data, it goes and processes the data and sends it back. You were going to say something.
Maybe it's a session, right? Like the right word for it.
Yeah. I mean, there is a stateful session. Absolutely.
Yes.
Yeah. In the web, in the traditional web world, you have this stateless. You're stateless, and then when you issue a request, the session is hydrated from a database or somewhere else. All the state is hydrated at request time. But you can think of, as a session, this session is just live constantly. And so that's a stateful component. And we think of the agent as that stateful piece. So it kind of is analogous to your web server or application server, except it's stateful, it's connected to one user, and it's also, connects in a multi-tenant fashion to an LLM on the back end. And so it's constantly processing your input streams. When you have a stateful service, how do you scale that? And so the way that we kind of architected this is also extracted from the work that we did with OpenAI. So your agent will connect to our servers, LiveKit Cloud servers. This is also available in open source, so you can do it yourself and you're not missing out on anything. But our server will manage a pool of your agents, figure out like how to take one out of the queue or out of the pool, connect with the user, monitor that session, deal with health checks, reconnection logic if it gets disconnected or crashes. And so there's that failover piece. And then once the conversation is finished or the session is done, put it back into the pool and kind of manage that whole life cycle for you. So that's the third part that the agents framework does. And that's like the first chapter. The problem with, I know we need more time, but like the problem with,
this is like super interesting, actually. I love it. Yeah.
The problem with the first version of agents, right? That's kind of what it provides today. And I think one weakness is that it's not quite flexible. What you've seen happen in voice AI is that there was a lot of hype that built last year around, advanced voice mode and all of these companies that are building voice-based interfaces. A lot of the ones that have become popular are pretty much like assistant kind of experiences, right? It's an open-ended conversation, or you're learning a language with like an immersive AI speaker, etc. It's very open-ended. It's not going through very complex flows. Most of the heavy lifting is actually being done by the LLM, and the LLM is a probabilistic computer, so it's as I said, it's an open-ended conversation that can go in many different directions. Now that the hype has started to die down a little bit from 2024, we're really turning our attention to, okay, this technology is real. It can be used for actual practical things. And not that an assistant isn't practical. There are very practical use cases, which I'm happy to talk about, but telephony and being able to go through complex call center workflows or patient intake at a hospital, these kinds of use cases have deterministic flows. You actually have a process in a call center, or patient intake is actually a great example. You have a flow where you talk to someone at the front desk and you're telling them what's wrong. You're looking at a calendar, figuring out when your schedules line up with the doctor, scheduling that appointment, and like then going and updating a record somewhere, collecting insurance information, verifying that it's still active. This is like a well-defined process. You don't want to just hand the whole thing over to a probabilistic computer and then 10% of the time it's not actually scheduling the appointment. What you want to leverage this LLM for is being able to process and output natural language. That's the magic of what that LLM does, but you still want it to move through this procedural flow that you have defined in actual regular old programming code, right? And so there's this kind of handoff or orchestration or bouncing back and forth between the LLM and then that deterministic layer of code. The first agents framework, like this first version that we have that's live today, was not built for that because it was extracted from what we did with OpenAI. It's very much like purpose-built for assistant kind of use cases, open-ended conversations, things like language learning, all of that stuff. Having a therapist, mental health therapist in your pocket that you can talk to. This new version of agents, which just dropped like maybe a couple weeks ago in beta, is Agents 1.0. This is not the official launch. There will be a more official launch, but you're hearing it here first on David's podcast. But Agents 1.0 is kind of now informed by where voice AI is going. It's going to proliferate into all these different use cases, a lot of them being telephone based because the telephone is this native input that uses voice, right? That we've been using for many years now, many decades. And so how do you actually build something beyond just a simple voice assistant with LiveKit? You can do it today, but it's really kind of a lot of elbow grease required. We're making something now that is purpose built for like modeling complex workflows, where you can kind of like have the agent call a function as an event and then like hand off processing to a task. And you can go through like a complex back and forth with voice to achieve the goal of that task. And this is the kind of the multi-agent scenario. And then you can kind of hand control back, and it can then delegate to another type of agent that is, I don't want to call it agent because it's this overloaded term, but you can basically string together multiple tasks that all do pieces of a larger, more complex workflow. And that's all kind of natively built into the agents framework. So that's chapter 2. That's like where we're going with
Wow.
it in the short term. And then there's chapter 3, which is like, where does agents go in the long run? And I think where that goes in the fullness of time is the LLMs are going to get better. They're going to be able to do more complex tasks, and they're going to need a runtime for being able to go and execute and do work on their own somewhere in the cloud. They're going to be able to need to use computers, need to use different types of tools on
Yeah.
their own, need to be able to see a screen and click a mouse and type in a keyboard and all of that stuff. And then if they get stuck or they need your help or you're collaborating with them, they need to be able to kind of notify you, contact you in some way, jump into a session with you, ask you some questions, maybe stream their screen in an interactive way where you can click in and help them, unblock them, and then they go back and they do their work. I think like we're moving through just at a macro level. We're moving from assistant to kind of co-pilot to co-worker. I think that that's kind of the progression of how this technology goes. And then even beyond that, then it's like humanoid robots. And like that's a whole nother use case where LiveKit is used in quite a few robot use cases. But all of these things are very exciting. The couple of things that I mentioned at the end there are kind of the direction that we will go over time, and building infrastructure that makes those kinds of co-worker kind of use cases easier for developers to build. But for now, very focused on kind of these complex workflows, multi-agent workflows that use your voice to interact with the computer in Agents 1.0.
Wow. All right. This is not how I was imagining
Me neither.
this
I'm so sorry.
conversation. No, no, no. It was, yeah. This is very, very interesting, Russ. I think this is an amazing vision that you have for LiveKit, at least the agentic part of it, right? And it's incredible to see how you basically, in your vision, how you're building on top of what's already there, right? Like this basic WebRTC low latency infrastructure, and then like the basic sort of agents with like for the assistant use case, this voice mode, and then going more into the agentic world, and where
Yeah,
you need to orchestrate different functions.
yeah. It's we didn't intend to kind of get into this space. It kind of happened a bit. I told the story a little bit about the demo that we built, and happened accidentally along the way. I think ourselves and a lot of other people, we realized that, okay, wow, like these computers are getting super smart. And so you're going to probably interface with them the way that humans interface with each other, because they're very human like. And that's the natural IO for a human is sight and sound,
Yeah.
and cameras and microphones are the equivalent sensors for a computer. That's the computer's eyes and the computer's ears. Um, and so WebRTC, as you said, like earlier, it's been around for a long time, pre-Gen AI, all of this stuff. And that's kind of, I think, the point is that we have a protocol that we've been using. We're using it right now to record this podcast episode. We have this protocol and this infrastructure, this technology that works really well for being able to see one another and hear one another and speak to one another in real time, this teleportation technology. And what we're doing is, with the agents kind of framework and platform, is we're giving that same kind of access to the technology that we've built for humans to connect with other humans now to a computer, so it can leverage the same thing. We don't have to reinvent the wheel. We just have to make sure that it's adapted well for the use case, and it works really well for machines being able to leverage it, and then and then also that it scales. Because there's going to be, in my opinion, a crazy ton more humans talking to machines than there will be humans talking to humans over the internet. I think humans talking to humans in real life and physical reality will still be, the most common thing. But
Yeah.
yeah,
And also like a lot of robots talking to robots
that's true.
using an audio, right?
Well, did you see that?
Maybe not audio.
Did
Yeah.
you see the Gibberlink stuff? There was
No.
it's pretty interesting. There was this 11 labs, I think, had a hackathon, and the winner of that hackathon, they used the OpenAI real-time API, and they built an app where they have two AIs talking to each other. And then what they say is like, you know what? It's just, I don't remember exactly the whole dialogue, but they say, hey, like, should we switch to a different format? Because, just speaking English is kind of low bandwidth. And then they switch. Like, you should check it out, the video. It starts making all these beeps and boops, and then the on the other side, on the receiving side, it shows the English transcript of what the beeps boops translate
Wow.
into, and they're just talking in beeps and boops back and forth to one another. It's
Wow.
really
All right.
amazing, but
I'm
it's
gonna
kind
check
of,
that. It's like
yeah,
a movie.
yeah. It kind of gives you an idea of like, maybe there will be like some other higher bandwidth format that these AIs talk to each other with. You can think of that. If it was the AI models talking to one another from like maybe the same company or the same provider, then they could just speak embeddings over the wire, just send vectors back and forth. But another even more interesting idea is, well, what if these AI models from different providers want to interoperate and talk to one another? What's that look like?
Isn't it what Anthropic did with MCP, right? I don't
And,
know.
oh yes,
I
MPC or
think
MPC.
MPC. Yeah.
I can't remember which with the ordering of the letters, but yeah,
I think
that's
that's where they're going with it.
I think
It's
so.
I
Yeah,
don't think it's for like audio and video
no,
yet, but
right.
why not? Right? It should
That
be.
that is
There
the
must
intent.
we need to have interop there. Yeah.
Yeah,
Well, very cool. So look, one last question,
please.
unrelated. I mean, a bit related. Do you guys have C++ SDK?
um,
I would love, to use LiveKit, but there doesn't have seem to be a C++ SDK that we can use from our application, which is like C++.
we do have one, kind of. So I say
Yeah.
kind of because there's a story here. Just gonna figure out how much can I say. So someone in the community developed a C++ SDK for embedded use cases, runs on like an ESP32 and all of that stuff. There's a few toy companies that are building voice interfaces in these toys using LiveKit and this ESP32 SDK. But that SDK that is actually working and integrated into these toys is in a private fork that we are
Nice.
now just about to get access to, handed off back to us, so we can turn it into an official SDK. And
Yeah.
so my
Okay.
answer is kind of, in that there is one. It doesn't work today. The private version does work, and it will become a public version that does work. So
Very cool.
stay tuned. Maybe in the next 2 months or so, we have one of my friends is joining LiveKit to kind of focus on this stuff. So he starts at the end of the month, end of March, and he'll get to work on it. So yeah, maybe 2 months, and we'll be there, and you'll be able to have something you can use.
Awesome. Yeah, we were looking for it for a while. C++ seems like to be an underserved language these
I think so.
days.
Yeah, but it's going to be
As you
used
go to
quite
like
a lot.
robotics, it makes a lot of sense to
Yes,
support that.
correct. It does.
All right, very cool. Thank you so much, Russ. This was an amazing podcast, and thanks for sharing your vision here. I love it.
Thank you so much for having me. It's an honor, and I apologize if I spoke for a really long time, but I really appreciate
No,
it.
I appreciate it actually. I sort of this made me think a lot about the future as well. So that's exactly the point of the podcast, right? So
Yeah,
thanks
oh,
for
it's so exciting. I think both what Crisp is working on and what we're doing. It's maybe we both didn't expect that we would be so kind of critical path to where this future of computing that I
Yeah,
think we all see now. And it's just an exciting time. I feel grateful to be part of it. I'm sure you do too.
absolutely, absolutely. It's exciting time, a bit crazy, but very exciting. So,
Yep. Agreed.
all right, thanks.
Thank you, David.